exponential function given by f of x equals a to the 2x, where a, e, and I are integer. A is an element of the integers. A is less than 0. The domain of the inverse is. So they're saying a is negative, right? So if they want the domain of the inverse, we want the range of the original, and that being negative. So the range of the original is going to be y such that, now exponential functions normally look like this, and then they go like this, or they go like this. This one is going to be down here because we have a reflection, because they told us a is less than 0. So y is less than negative 5, y-e-r. So you have to make sure that you always read thoroughly these bad boys here. So that gives you a hint, right? And then the domain of the original, or the inverse, sorry, is going to be x such that x is less than negative 5x, which is C.
No, but it's a is less than 0, so it is negative.
A is less than 0, so A is negative. You guys got to read your variable sample. Variables. Better to learn now than Wednesday. Okay. 2. The equation log b plus 1 3m equals a half can be written in terms of, so we have a log, we want b by itself. B is in the base. The only way we can do that is converting it to exponential. There's a 1 in front, so we're golden. We have 1, 2, 3 pieces, so we can convert it right away. So we go b plus 1. The base of my log becomes the base of my exponent. What's with it doesn't stay with it. In order for this to be a base of an exponent, it needs an exponent, which is a half, equals 3m. And then how I get rid of a half is squaring. This is not a binomial, it's just a monomial squared. So I'm going to get b plus 1 equals 9m squared. Don't forget to square the front number. And then minus 1, which is a.
You know what? I need to understand why
Wait, what? No, I do not understand what I'm saying.
Oh, okay, I see. Yeah, that was a stupid mistake.
It'll get you.
And ask for this one.
Wait, why does it have 9?
Because 3, you have to square the 3, which everyone doesn't do.
But then you keep what?
Why do you keep the square?
Because it's on the m, guys. You're squaring two numbers.
Oh, right. You have to distribute.
You know what that is? That's grade 10 exponents right there. That'll get you. That'll get you. You know, it'll get you when you least expect it. I got a real grade 10. Okay, so for this one, it says, what is the y-intercept? Y-intercept means x equals 0. So when I go to do that one, I'm going to do it off the side. I'm going to get f of 0, technically, or you put f of x, doesn't matter, equals a b to the 0 plus d. B to the 0 is what?
0. 1.
It's 1. So this is going to be a 1, so it's going to be a plus d. So my y-intercept is a plus d. And it says f of x has an asymptote that can be written in the form of blah. The y-intercept is in the form of blah. So a plus d, which is 4. It's not y equals 4. It's y equals the first code. The first code is 4. F of x has an asymptote that can be written in the form of, so in order for it to have, it's an exponential. Remember, exponentials normally run like this. We're going to read what it says here. It says a, b, and e are integers. B is greater than 1. So we know that b is it's a growth. So it's going to look like this. And like this. But then we move it d up. Correct? So f of x has an asymptote that can be written in the form, what is that? Y? It's going to be y equals, that's an equal sign. So it's y equals, because it's horizontal, it equals what? D. So it's going to be 7, 2. No. There's nothing about inverses on this at all. An exponential function has a horizontal asymptote, always. And the only thing that can move it is the vertical translation.
Well, it was starts with an A as well. That's why it confused me. What's the word from last unit? It starts with an A as well. That is.
Oh, you're talking amplitude?
Yes, I keep confusing asymptote and amplitude. Yeah, so I use A. That's a rookie mistake. Yeah.
Rookie. Yeah, true. Okay, now we have a log function. Log functions always have vertical asymptotes. The only thing that can move a vertical asymptote is a horizontal translation. So I'm going to get log base b of a x plus b over a. So my horizontal translation is actually minus b over a. This baby is not negative. A is greater than 0. So it's going to be greater than sign because a is not negative. And negative b over a because it has to go to the left. Oh, good job. I'm so proud of you. 4 asks for the y-intercept. When it gives me y-intercept, I always plug in x equals 0 and I plug it into my original. So I'm going to go f of 0 equals log base b of a times 0 plus b. A times 0 is just 0. So this is actually log base b of b, which is just 1. Remember, if you're stuck, you can go log base 2 of 2, log base 3 of 3, log base 4 of 4, log base 5 of 5, log base 6 of 6. Try things out. You'll get 1 every single time. If you're stuck, you can always plug them in with numbers. Trial and error. Number 5, we have to make common base. So we're going to get 3 to the x squared plus x. 27 is 3 cubed. To the 3x minus 1. Yeah. Equals 3 to the 1, which I'm going to put as a 1 so I don't forget it, because I have to add a 1 to it. And then I'm going to get 9, which is 1 over 9 is 3 to the negative 2 to the x minus 2. So here I'm going to get 3 to the x squared plus x over 3 to the 9x minus 3 equals 3 to the 1 times 3 to the negative 2x plus 4. Here we subtract exponents because it's division. Here we add exponents because it's multiplication. I don't know why I have brackets in weird spots. But so here I'm going to get 3 x squared plus x minus 9x is going to be minus 8x. And then minus a minus 3 is plus 3. So it's x squared, and then x minus 9x is minus 8x, plus 3 equals 3, negative 2x, and then these ones we add. 1 plus 4 is 5. So then I can set the exponents equal. X squared minus 8x plus 3 equals negative 2x plus 5. And they want it in positive x squared, because you have to add the 1. 1 plus 4 is 5.
No, the 3. Why is 3 on positive? When you did
Because you're minusing 3.
Oh my God.
You're minusing negative 3. You're going x squared plus x minus 9x plus minus a minus 3. Because these are division, you have to subtract the exponents.
Yeah, I got that, but I don't know, what are you subtracting?
When you minus,
When you minus a negative 3, it's a plus.
You're minusing it because it's division.
Yeah, no, I understand that.
You're subtracting it from 0 because you don't begin with anything that is.
Yeah, so it'd be like 0 minus a minus
I was
3.
asking what you were subtracting it from.
Oh, nothing.
0.
Because there's no like terms.
Thank you.
You're welcome.
That's so hard.
It actually seemed to be, yep, it was.
Jeez.
Okay. Now it says the value of C is C, negative 2. Now, if you're stuck and you want to see if you did it right, you could actually, because this is just a part way through, right? Like I didn't solve anything, I just got part way through. What you could do is you could type the original in and do y1, y2. Type this in, y1, y2, and you should get the same answers, right? Because it's still part way through. You'll just only get one answer up there because you won't get the extraneous one. All right. Then we have 2AB equals C in the expression B. The problem here is people will put the 2 with the A. The 2 is not with the A. If the 2 was with the A, it would be in brackets to the B. Don't fall to this one. This one people fall to all the time. This is 2 times A to the B equals C. If it was with the A, it would be like this. Is it? No. So what's the first thing I actually have to do?
Divide the 2 over.
Divide the 2 over before I can convert.
That is so.
So I get log base A of C over 2 equals B. And they want to know what B is? It's log base A of C over 2, which is D. I did not mean to do that. I don't even know what just happened. This one says the following statements are made about the function a 2 to the x minus 1 plus d, and you have to watch yourself. You have to see what the variables stand for. So a and d are integers, and a is greater than 0. So we do know that a is not reflecting, correct? Because if a was reflecting, our domain would be our range would be y is less than d, right? But it's y is greater than d because our a is positive if they ask us for range. Okay, it's exponential. Exponentials have horizontal asymptotes. The only thing that can move it is a vertical translation. If you quickly sketch an exponential, you'll see, oh, the only thing that can move that is a vertical translation, and it's horizontal because it's horizontal. So the y-intercept, in order to find the y-intercept, you have to fill 0 in for x. So I'm going to go f of 0 equals a 2, 0 minus 1 plus d. And then a, what's 2 to the negative 1? A half. So it's a over 1. So it's a over 2 plus d, which is true. Then there's an asymptote at x equals. There's never going to be an asymptote at x equals. X equals are vertical asymptotes. It's not going to happen on an exponential function. There is an asymptote at y equals are horizontals, y equals d, which is true. It's y equals your vertical translation. There can never be an x-intercept. Is that true? Right, they're just integers, right? Your d could actually technically be negative. It says a and d are integers. So your d could be a negative number even though it says plus d. There's an x-intercept when d is less than 0. That's true. When d is less than 0, it drops your graph below and the whole graph's above. And then the inverse function will have a domain of xer. No, it'll have a domain of x is greater than d. Because the range of the original, this one has a range of y is greater than d. So this is going to have x is greater than d. So the true statements respectively, which means in that order, are 1, 3, and 5. Did you guess every single wrong one?
Yeah.
Oh, you even reasoned that 4 was wrong. Right now.
Yeah. Well, I didn't put that one down. Oh,
Oh.
actually, I did. Because I was in a rush.
Oh, gosh.
Like,
Mhm.
you were-
Yeah. Can't take you seriously with those glasses and that visor. Okay. So the rest of this, I'm only going to give you probably about the same amount of time tomorrow to do as much. So I want to be able to get through all of it. So I'm going to ask you to do 7 to 11 at home. 7 to 11 at home.
Yes, sorry.
Because I want you to be able to do 4 to this and me be able to go through them all, right? Because if I can't go through them all, what's the point of doing them? You won't even know if you did it right or not. And honestly, sometimes you need to see something and do it wrong so that the next time you see it, you don't do it again. Better to find out before the test than to find out on the test. Okay. Can we go to our notes? I want you to go to here. Permutations with restrictions, continue. So, here it says the number of permutations in the word kitchen. Now this is what I'm going to get you to do with all of your words, is you're going to rewrite them out. Now it's going to look really stupid right now because we have no doubling and tripling up. But, I'm going to go Kitchen, and the reason why I make you rewrite it is to count it out properly, but also if you had the word pool, let's say, you would go Pool. Shh. So you would stack them if you had the word pool. Okay? Whereas kitchen doesn't have any double, triple letters, so you just literally write it out. Now the reason why we do that is if you write out the word and there's no doubling or tripling letters, then you'll know there's no repetitions. If you have not started your cumulative yet, I'm going to pray for you. That's a lot of faith.
Uh-oh.
What do you mean? Still same thing. Yeah. Okay. Paying attention so I don't lose you on this next step. So here it says, find the number of permutations of the letters in the word kitchen if the letters K, C, and N must be together but not necessarily in that order. So pay attention. How many letters are in kitchen? 7. So I'm going to have 7 blanks, and each blank holds a letter, right? Now, it says that the K, the C, and the N have to be together, so I'm going to hook them together. So, I want these ones to be together, so I'm going to hook them together. I'm hooking together 3 letters. Now, if it was KCN in that order, I'd go KCN 111, right? But it says KCN not necessarily in that order. And what I tell you about kitchen, or any words, they're on Scrabble tiles, right? So I have 1 K, I toss you the Scrabble tile. I have 1 I have 1 T. It's not an unlimited number. So you're always boxing like I told you to do when you can't repeat, correct? So for the first blank, I would have the options of K, C, and N. So how many options do I have? 3, and that's what I list above. But how many letters am I leaving there? 1. So I'm going to pretend to leave the N. I'm going to box it. Then I would have K and C for this blank, so that's 2. Box it. And then I would have a K, which is 1. Box it. So now I've used up K, C, and N. Yep.
Do you have to repeat the letters
No.
underneath? You just do it in your head.
Yeah, as long as you don't mess up. And then how many letters do I have left for this blank here? 4. I'll show what they are. I, T, H, E. So I have it. So I have 4. Then how many do I have for here? 3, then, and I need all these letters to make the word kitchen, right? Now this would actually be the answer if I said K, C, and N must be together at the front. But did I say that? No, I said K, C, and N must be together. Now you're paying close attention because this is where I'm going to lose you. Okay. These are the letters, it's I, T, H, and E. Here's the 4 letters, correct? And here's K, C, N stuck together at the front. Do you see that? Okay. This is one way I can have them. They would be at the front. Or I could take these 3 letters and I could put them here, correct? But it would still be 4, 3, 2, 1, 3, 2, 1. So same answer, just out of order, right? If I go 3 times 2 times 1 times 4 times 3 times 2 times 1, or I go 4 times 3 times 2 times 1, 3, 2, 1. Same answer, correct? Or I could put them here. 4, 3, 3, 2, 1, 2, 1. Same answer if I multiply all of those. Or I could put them here. 4, 3, 2, 3, 2, 1, 1. Or I could put them at the back. 4, 3, 2, 1, 3, 2, 1. Same answer if I multiply all those numbers together, correct? So we just have to come up with all the different cases that would give me that same answer and multiply all those cases, correct? So what I always do is I will use 3. I say, okay, this is one way, the way they are, with them at the front, correct? Then I could take these 3 letters and I can put them between here. So how many ways is that now? And then here is, and then here is, and then here is 5. Now just so you know, the number of cases that I can make out of this is always one more than the hook together, the number after the hook together numbers. So what number is this? 4. So how many different ways am I going to have? 5. It's always one more than this number after they're hooked together. Because this gets me 1, 2, 3, 4, 5. So I just multiply by 5 at the end. And I multiply with the multiplication symbol just to prove the point. Now, I could type this in as 3 times 2 times 1 times 4 times 3 times 2 times 1 times 5. I could absolutely do that. Or, what is 3 times 2 times 1? 3 and then factorial, yeah. And then what is this? This is where I lose people. 4, 3, 2, 1 is 4 factorial. Everyone's good with that. But if I put 4 factorial times 5, what's that just the same as? 5 factorial. Because it would be 5 times 4 times 3 times 2 times 1. I can make them in any order, right? 5, 4, 3, 2, 1 blast off is 5 factorial. So it's going to be 720. Now, are you ready? This is where I lose people. Like super lose people. Put your pencils down. Pencils down, ears listening. If I asked you how many people are in this school but not in this classroom, what would be the fastest way to figure that out?
The amount
Doing
of
what?
people in the school minus the amount of people in this classroom.
The amount of people in this school minus people in this classroom. Every single one of you could answer that question like that. No problem. Then I give you this, and you guys try and do it differently. So what did you just do to do that? You said, how many people are in this school, Mrs. O? She tells you. And you say, hey, Lepp, how many are in this class? And I tell you. And then you subtract them, and boom, you have the people not in this class, right? That's the fastest way. To take total minus the people in this class, left over is the people not in this class. We agree? So let's look at this example. This example says, the number of permutations or arrangements or order matters of the letters in the word kitchen if the vowels must not be together. So if I want all the cases where the vowels aren't together, what I can do is find the total like you did of the school, right? I can find all the total, no restriction ways I can do kitchen. So how are the total no restriction ways I can do kitchen? How many letters would be for this blank? 7, then 6, then 5, then 4, 3, 2, 1 with dots. What is that short form? 7 factorial. That's it. That's 7 factorial, I think it's 5040. It's the absolute maximum number of different words you can get from kitchen. That's it. Okay? So I'm going to write that as 5040. So that is, the answer to B has to be less than 5040. Because 5040 are all the different words I can get from kitchen. Right? Now, if I take all the words from kitchen, which is 5040, and I subtract off the vowels together, what's left over? If you took the total number of kids in this school and you subtract off the ones in this class, what was left over? The ones not in this class, correct? So if I take the total number of words in kitchen and I subtract off the vowels together, what's left over? The vowels not together. That's it. Because what's the opposite of vowels together? Vowels not together. That's the opposite, correct? Opposite of people in this class are people not in this class, correct? Opposite of vowels together is vowels not together. So if I take the total, no restrictions, and I subtract off the vowels together, I'm left with all the cases where the vowels are not together. How many vowels are in the word kitchen? 2. So I'm going to hook them together just like I did with the KCN, right? What? I have a minus sign. 1, 2, 3, 4, 5, 6, 7. I hook the 2 vowels together. How many letters do I have for this first option? 2. The I and the E, correct? Then I leave one there. How many do I have left for here? 1. So just the I. Then how many letters do I have left for these blanks? 5, then 4, then 3, then 2, then 1, and then I'm done? Am I done? Oopsies. That would be vowels together at the front. Is that what I said?
Anywhere.
I want vowels together anywhere. So how many ways can this happen? How many ways can I move this? 6. It's always one more than this number, but I'll prove it. 1, 2, 3, 4, 5, 6. So I get 1440. What's 5040 minus 1440? 3600? Yeah.
So could you do for the second one just like 2 times 6 factorial?
Yes. That's all I did, because I went 6 factorial and I had 720 times 2 is 1440. Because I have no childhood memories and I have the factorial answers memorized. Sad place to be. All right. I don't even know. I don't know. Did I go to kindergarten? I'm not quite sure. Those memories I've lost. All right. So in how many ways can we do oranges? Well, first off, what we're going to do is we're going to write out oranges. O, it's going to look stupid, and I don't care. In a second, it will matter. O-R-A-N-G-E-S. If I write the whole word just back out again, it means I have no doubling or tripling letters. I have just one O, one R, one A, one N, one G, one E, one S. Now here it says oranges, if there's no further restrictions. No restrictions on the word oranges. How can I, many times can I rearrange it? I can't speak today. How many letters are in oranges? 7 factorial. Because it would just be 7 times 6 times 5 times 4 times 3 times 2 times 1. 5,040. Then once there's restrictions, you have to deal with the restrictions first. So the first letter must be an N. 1, 2, 3, 4, 5, 6, 7. This one has to be an N. How many options? 1. Can I move it? It says first letter, so there's no moving. Right? Then how many letters do I have left? 6. Then I place one there, then 5. Then I place one. 4. Place one. 3. Place one. 2. Place one. 1. And I get 6 factorial of 720. C says the vowels must be together in the order OAE. 1, 2, 3, 4, 5, 6, 7. Does it say together at the front? No, it just says together in the order OAE. OAE. How many options? 1, 1, 1. How many letters have I used up? 3. How many do I have left? 4 then. 3, 2, 1. And how many ways? Times? How many?
Times 5.
Times 5. It's always one more than this, but if you don't remember, this is 1, 2, 3, 4, 5. So it's technically 5 factorial, which is 120. How many arrangements of the word brains are the vowels together? B-R-A-I-N-S. B-R-A-I-N-S. This has 6 letters. How many vowels? 2. So I have A-I, 2, or I, let's say, 1. How many letters have I used up? 2. How many do I have left? 4, 3, 2, 1. Am I done? No, what do I have to multiply by? 5, because there's 5 places they can be, because it doesn't say together at the front. So this is 1, 2, 3, 4, 5, or one more than the number after the hook together. So it's 2 times 5 factorial, which is 240. The next one says 3 girls and 4 boys have to be arranged in a row. Arranged means it's permutation, correct? And arranged means I can do blanks and you can literally see me placing them in seats in a row. So how many seats are there? 7. 1, 2, 3, 4, 5, 6, 7. I'm specifically leaving space because I'm going to ask you another type of thing after this. So 3 girls, 4 boys arranged in a row. No 2 people of the same gender can be together. So what am I going to have to start with? Boys, yeah. So I have to start with boys because there's more of them. So I go boy, 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 boy. How many options of boys do I have for the first blank? 4. Then this one. 3. Then this one. 2. Then the last one. 1. And I have to fill the rest in with girls. So I have 3. Then 2, then 1. Now I made them different colors so that you could see the blue makes something and the red makes something. What does the blue make?
4 factorial.
And what does the red make?
3 factorial.
So I can just go 4 factorial times 3 factorial. $144. Now, I'm going to change it up. I have 4 girls, 4 boys. Do the question. They can't sit together. Started with the boy in the first one. How many started with the girl? Would that look different if you started with a boy or if you started with a girl? If you looked at a picture, could you tell the difference? You absolutely could. If you looked at a picture and you had a girl, boy, girl, boy, girl, boy, and then I gave you another picture and it was boy, girl, and I'd say spot the difference, you'd be like, they're different, right? You would. You would know. Okay? Because they would be holding B, 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 and then G, G, G. So don't play me. You'd know. You could tell. So we have 2 cases. 1, 2, 3, 4, 5, 6, 7, 8. Or 1, 2, 3, 4, 5, 6, 7, 8. So watch out when they're even numbers. People will mess this up. So I could start off with a boy or start off with a girl. So this would be 4, 3, oops, I got a little aggressive with my dots. 2, 1, and then I would supplement 4, 3, 2, 1 for the girls. And this would be 4, 3, 2, 1, or 4, 3, 2, 1. So it's actually 4 factorial, which a lot of people have the answer of, but times 2.
Never mind.
So what do you get? What's 24 times 24 times 2? How much? 252? Okay, then we're flipping over.
1,152.
Oh, that's not even close. That's just sad. I was like 24 times 24. That's perfect. 1,152?
Yeah.
Oh my gosh, I'm hearing nothing right. 1152. What I'm going to use as a real number. Okay. Next page. Repetitions. Repetitions. We have words with letters that double. Not until today.
It's not just be the same, you just have like an extra number or extra letter to use.
No. So we have the word basketball. Look at this. I have the word basketball, and then I retyped it. Are the 2 words different? No. Ha! I switched the L's.
There's no repetitions you have to do.
We're going to have to get rid of all the cases where they double up, which sounds extensively hard, doesn't it?
Yes.
It's not. You just divide by the factorial of the doubling or tripling letters, and it gets rid of the problems for you. This sounds like an extensively hard problem. It's not. So if you remember to write down your letters with stacked letters, you will remember to divide by the factorials, and you'll rock every question. This is no harder than the previous ones. You just end up having to divide by the factorials. So let's say basketball. Basketball is B-A-S-K-E-T-B-A-L-L, right? And I just want to rearrange basketball. How many letters are in basketball? 10? I think. 4, 8, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 factorial would go on the top, correct? If I was rearranging 10 letters and had no restrictions, I'd just go 10 times 9 times 8, 7, 6, 5. Yep. But I just need to divide by the factorials, and it gets rid of all the problems. So I have to go 2 in brackets. If you don't put it in brackets and you didn't put it in a fraction, it'll do 10 divided by 2 factorial times 2 times 2, which makes it really large, not small. So 10 factorial divided by 2 factorial for the B's, 2 factorial for the A's, 2 factorial for the L's. You can't do 6 factorial. Why? Because 2 times 2 times 2 is 8. 6 factorial is 720. Substantially larger number you're dividing by. Not correct. Okay? So what's 10 factorial? Make sure you put in brackets 10 or in a fraction. 10 factorial divided by 8, or 2 times 2 times 2, is 453,600. So I can ask you any of the exact same questions. The only thing that's going to happen is you're going to divide by the factorial. And you treat, like if there's 2 O's, you treat them like they're different O's. That's it. Okay. We're going to look at aardvark. The A's must be together. So the first thing I'm going to do is write out the word. A, R, D, V, A, R, K. Do you know what I do? I do this. I do it before I even do the question, so that I do not forget to do the division. Like, I don't even care what the question says, I immediately do that. 3 factorial for the A's, and 2 factorial for the R's. You see why you stack? At least if you stack, you might be like, why am I stacking these? Oh, yes, factorials. People will stack them and still not write factorials. I don't know, I'm just wasting your time. Okay. Aardvark, the lovely word, has 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. The A's must be together. Does it say at the front? Or does it say start with the A's or anything like that?
No.
No. How many A's are there? 3. And we're not going to go 1, 1, 1, guys. We treat the A's like they're totally different letters. And then the division just gets rid of the fact that they're not. Okay? So for the first blank, how many A's do I have? 3. Then I leave an A there. How many A's do I have for the second blank? 2. And then how many A's for the third one? 1. Do you see how I treated them like totally different letters, even though aardvark, and and then all looks the same? I'm selling bad sheep. Scrabble tiles, yes. So we have 3, 2, 1. You're treating them like they're just, yeah, they're Scrabble tiles. Then how many letters do we have left? 5, then 4, 3, 2, 1. And if it said start with the A's, we'd be done. But it says together, so how do we have to multiply it by? 6. Oh, is one more than this. So I'm going to get 3 factorial, 6 factorial, over 3 factorial, 2 factorial. These bad boys cancel. So it's going to be 360. Vancouver must start with the V's. So am I going to have any movement? No. So I'm going to do Vancouver in green. V-A-N-C-O-U-V-E-R. Don't care. 2 factorials going on the bottom. Wow, I did not line the V's up. That was stupid. Vancouver has 3, 6, 9 letters. Starts with the V's, but they're not moving, right? It has to start with the V's. How many V's do I have for the first blank? 2. Then 1. Then I've used up all the V's. How many letters do I have left? 7. Then 6, 5, 4, 3, 2, 1. And I'm not going to move them because it says it has to start with the V's. So I get 2 factorial, 7 factorial over 2 factorial. These are all multiplied. The 2 factorials cancel. I'm left with 5,040. Then I have mathematical. Who wouldn't like that word? Everyone would like it. So, ath, e, math, a, t, ka, a, o. So, boom. 2 factorial, 3 factorial, 2 factorial. 5, 6, 7, 8, 9, 10, 11, 12. That's a long word. How many vowels are in mathematical? 5. And I treat them like they're different. So how many Scrabble tiles do I have for this one? 5. And then 4, and then I leave a Scrabble tile. 3, then I leave a Scrabble tile. 2, then 1. I've losed up. Yeah, I'm a loser. I have used up 5 of 12. So how many are left? 7. Then 6. This one part of my board goes wonky now. 5. I think it might be because I hit it hard. 4, 3, 2, 1. I'm just guessing. I haven't hit it hard in a while, but it has sometimes in the past. When it doesn't work. Okay. What do we have to do? No, what do we have to times it by? 8. It is your bad. Just kidding. So we're going to get 5 factorial, 8 factorial in brackets, divided by 2 factorial, 3 factorial, 2 factorial in brackets. How do you guys not get excited for listening to my podcast? It sounds like I'm literally screaming. It's awesome. Terrible. I like turn it down to the lowest volume and I'm still like, okay, so the next thing we're going to do here, that's what I sound like, it's awful. You're welcome, it's a gift. I don't listen to them, only you get the pleasure. All right. These ones are, see, I get excited and then I scream. It's just a problem. It's raising voice, but it sounds like screaming. Example 3. What we're going to do is we're going to treat this like, doing monotone. We're going to treat this like there's downs and rights. Get ready. It's going to be fun. Okay. This would be, paying attention, I will lose you. I've lost people for easier things. This I will lose you. So this is down, this is down, this is down, this is down. Do you see that? You could label them, you could label them B, 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 B. You could label them C, 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 C. I label them D, D, D because I treat them like down. That's it. That's all. There's no other fancy way. They just have to be all the same letter. Okay? Then I'm going to label these rights because it's right. But if you want to label them A's, you can. It doesn't matter. Just that you put one above each line. Do you see that? I picked this because I should really do BR because burr sounds a lot better than der. I sound like a dummy. But now I have the word der. I have duh, der. Okay, if I were to arrange der, I would stack some letters, wouldn't I? What would I stack? 4 D's, so that would be 4 factorial on the bottom, and 5 R's, correct? Boom. I'm a rock star. I'm halfway done the question. What would I put on the top? How many Scrabble tiles are there?
What?
No way of adding that to 16.
At least 6.
I appreciate your effort. No, how many letters? Guys, I wrote out the Scrabble tiles. Can we count them? How many Scrabble tiles?
I don't know why when you said Scrabble tiles.
There are 9. Thank you.
I thought she meant.
Yes. 9. Thank you. Yes. So there are 9 Scrabble tiles. They're right here.
I was right, I said at least 9.
So we would go 9 factorial on the top. So we put 9 factorial on the top because we would go 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. So that will get us oh my gosh, 24 times 1. Pressing buttons and then I'm drinking. 126. Now, paying attention. I'm going to show you how it actually works with pathways. Do not memorize how to do this method. It will not be asked of you. I'm just showing it to you so that you trust that I'm not making up crap and that there actually is 126 paths from A to B. Okay? Do not copy this. Do not try and represent it. Don't come on at lunch and ask me how to do it. This is not part of the curriculum. This is part of the curriculum, right? Because it fits in what we just did. Yes? Okay. So, what I can do is I can add the paths as I go along. I have to go from A to B and I can't circulate back or there'd be an infinite number. So this would get me one path to get to this spot and then one path to get here and here and here and here because I could just walk there, right? And then I have one path to get me to these spots. I could just walk to them. Then what I do is I sum up the paths. So if I have one path coming into here and one path coming into here, that's a 2 total paths. 2 and then 1, this is 3. 3 and then 1, this is 4. 4 and then 1, this is 5 total paths. 5 and then 1 is 6. 1 and 2 is 3. 3 and 3 is 6 paths. 6 and 4 is 10 different paths to get me to this exact intersection. 10 and 5 is 15. 15 and 6 is 21. 1 and 3 is 4. 4 and 6 is 10. 10 and 10 is 20. 20 and 15 is 35. I'm doing this aggressively fast so that you don't try and copy me. 21 and 35 is 56. 1 and 4 is 5. 5 and 10 is 15. 15 and 20 is 35. 35 and 35 is 70. 71, 56, it's 126. And it matches! Drop the mic. I'm a genius. Yes. Yeah, I thought you were going to ask me if we had to do that. I was going to be like, girl, please. No! I did it fast, so it's not. What if we have two of them? I would go do that factorial, and then this one I would go boo. And I would figure out that word, and then I would just multiply the answers. So it would be 4 factorial divided by 2 factorial for the dir, times, for the boo, it would be 5 factorial, because it's 5 letters, divided by 2 factorial, 3 factorial. You know what I'm saying?
Yeah.
Dir and boo. If you flip over here, you'll see there's so many homework questions, so little time.
Yeah, no.
I'm studying.
The reason why there are so many questions is because they're all a little different and you need to practice them because it's permutations. Hence why I said January 2nd.
Yeah.
Exactly.
January
Yep.
1st.
Is it all of this?
Yes. It sounds ridiculous. I agree. But I'm letting you guys have till January 2nd. And honestly, the more perms and comms questions you do, the better you'll get at them because they're weird.
Can you give us more than that?
That does this? Yeah, I'm just like, Did you know that?
Reason we have.
I don't think so. But there's matrices that used to be in here, and then what they would do in matrices in applied 30 before it was dash 2, they would put like a little lake in here, and you have to go around the lake. And how many factors?
Why though? Like why?
In case you are making a park with paths and a lake.
Take a random fact. You don't have to calculate.
No, you. Yeah.